I am Bharat. I will discuss about limit point. Limit point of a set. First definition. What is the definition of limit point? A real number x is a limit point of a set S. You can write it is subset of R if every neighborhood of X contains an infinite number of members of S. So this is the definition of limit point. Again I repeat, a real number x is a limit point of a set S if, this is we have to remember, every neighborhood, this is the condition, every neighborhood of X contains an infinite number of members of S. That means if we take a point X and we draw a neighborhood about this point X, then X is called limit point if it contains so many or infinite number of points of S, and this infinite number of points must be in S, belongs to S. That means this neighborhood must contain infinite number of points of S. This is the definition of limit point. And there is another terms of limit points. One is cluster point. You can say cluster point. Then condensation point. Condensation point, or you can say accumulation points. These are the other names of limit point. Accumulation point. So these are the other names of limit points in different books. You can find these names for limit points also. So just to give some example for the limit points, how can we understand what are the limit points? For example, suppose a real number set R. The real number set R. So in this case, every point of the real number set, or every point of R is a limit point. How every point is a limit point of R? Suppose we take this is 0, 1, 2, -1, -2, and in between 0 and 1 so many, suppose 0.1, 0.2, 0.3, 0.4, 0.5, 6, 7, 8, then 1, 1.1. There are so many real numbers in between 0 and 1, in between 1 and 2. Just I write the integers, the whole numbers. So integers I write 0, 1, 2, and in between these integers there are so many real numbers. Suppose we check for 0 whether 0 is a limit point or not. Suppose I draw a neighborhood about 0. So if I draw neighborhood about 0, then it contains so many real numbers. Say here, see, there are so many real numbers in between this. In this neighborhood there are so many real numbers. Again, just if you decrease the size of neighborhood, if you take this neighborhood, then again see there are so many real numbers, infinite number of real numbers in that neighborhood. Again, similarly this. Again, suppose if you take about 1 is also a limit point, 0 is also a limit point. Similarly 2 is also a limit point. And in between all the points, in between 1 and 2, if you take this is a point in between 1 and 2, then this is a neighborhood about this point. So also it contains so many members of the real numbers. So you can say every point of R is a limit point of R. Okay, another example, integer set. Integer sets, set of integer set I, integer set I, integer set I. If I denote it by I, the set of integers. So similarly you can show like this. It is 0, it is 1, 2, it is -1, -2, -3, this is 3. So now here this is the difference between in the first case, in the first example, in between 0 and 1 there are so many real numbers, but here only the members of the integers are 0, 1, 2. There is no points in between 0 and 1, means there are so many points, but these are not the member of I. The members of I are -3, -2, and these are negative numbers, then 0, 1, 2, 3, like this. Okay, so this is the difference. There is no, means the points in between 1 and 2, between 2 and 3, they are not the members of I. So we have to only consider the members of I. So here if I draw a neighborhood about 1, then 1 contains only 1, but not members of the, here the members, means next member is 2, the previous member is 0. So it does not contain any member of S except 1. Except 1, it does not contain any member of the set I. So but what is the definition? Every neighborhood. Our definition is every neighborhood of X contains an infinite number of members. Okay, but here this neighborhood, I got a neighborhood which does not contain any member of the set I except 1. So 1 is not a limit point. Again, for 2 also we can get a neighborhood which does not contain any member of set except 2. So 2 is also not a limit point. So similarly you can check, this is not a limit point, 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 this is not a limit point. So these are not the limit points. So here we write, or we can write, the set I has no limit point. Another example, if I consider the closed interval of 1 and 2, closed interval of 1 and 2, here the points includes, what are the points? You can write here 1 less than equal to x less than equal to 2. That means all the points in between 1 and 2, including 1 and 2. This set contains 1, 2 and the points in between 1 and 2. So here similarly you can consider this is 1, the last point is 2, and all the points, all the real points, all the real numbers in between 1 and 2, all the real numbers in between 1 and 2. So if I consider, or if I check for 1, then I draw a neighborhood. It contains so many real numbers here. Again if I check for again I draw a small neighborhood, then again also this contains so many real numbers here. So 1 is a limit point. Similarly 2 is also a limit point. Again all the intermediate points, suppose this is point, this is a point, 1.5. so if I draw the neighborhood, then it contains so many real numbers here, so it is not a so it is a limit point. So similarly you can check every point. So here we can write every point is a limit point. Every point is a limit point. So another example, suppose we consider open interval of 1 and 2. Open interval of 1 and 2. What does it mean? Open interval means what? 1 less than x less than 2. That means all the real numbers in between 1 and 2. Difference is what? In the previous example, it includes 1 and 2, but in this example, it does not include the number 1 and 2. Only we have to take the numbers in between 1 and 2, all the real numbers in between 1 and 2. So in that case, suppose I take this is 1, this is 2. So 1 is not a member of that set, 2 is not a member of that set, but if I take 1, or if I check for 1, then I take a neighborhood. Then here you can see there are so many real numbers in between or in this neighborhood. That means it has members of real numbers which this neighborhood contains. Again, you can take any neighborhood of 1. It contains infinite number of points of that set. So 1 is a limit point. Here we can see 1 is not a member of the set, but 1 is a limit point. Similarly 2 is not a member of the set, but it will be a limit point. And the intermediate points, these are the limit points. All the points, if I check for all the points, then all points will be limit point. But we have to note, means it is to be noted that the points which are not in the set, they may be the limit point of that set. So we can write all the points. Again here every point is a limit point, and we can find another result. What is the result? Limit point may limit point of a set may or may not be a member of that set. Thank you.